So we're going to take some notes over 2.5, which is going to be the big idea is 2.5. Again, these is going to match up. Notes is now going to match up with big ideas assignments. So this is for 2.5. We're going to be talking about compound inequalities. So usually they're written in the form of, actually there's one right below us here, x is less than or equal to -2, or x is greater than 3, which is right. All I did was steal that from down below. In interval notation, just because we're going to have that pop up with us, actually, well, let's just do it down below here. So we have a closed circle. At -2, it's everything to the left. We're going to have an open circle at 3, and it's going to be everything to the right. So that's what that graph looks like. If we convert that into interval notation, we're just going to have two intervals. So I have, it's going to go on to infinity, so it's a negative infinity. My right boundary of that is -2. It's going to get a bracket because it's being included. And then we're going to put our little union symbol here. Of the other interval, 3 is going to be the left-hand boundary, and we're going to get a parenthesis on that, if I could talk, and that goes to infinity. So that's what the interval notation answer looks like. We're also going to have, making sure that these are all, we have some AND problems. It has its own section. And again, I'm stealing somebody else's notes, and I really don't know what they're after here for certain things. So we'll just use it as we're going to use it. Or inequalities tend to have a graph. I'm going to call it ORs, because if we had a boat here, we're in the boat, and we got an OR on each side of the boat. So we'll pretend that that's what it wanted to do. Okay. So it wants us to solve and graph each interval notation. So again, there's nothing special about solving these. We just have to pay attention. Sometimes they'll overlap, and we'll have a different answer. But I'm going to add 4 to both sides, and we're going to get x is less than -3. So we could go ahead and graph that one. Now there's no sense in doing the, I'll do both of them on notes, I guess. So we're going to have an open circle at -3, and it's all the values that are left. If we divided the 2 out of here, we're going to get x is greater than or equal to 6. So that means I'm going to have a closed circle on 6, and we're going to go that direction. The interval notation, again, I would have had a parenthesis and gone that direction. I'd have had a bracket and gone this direction. So again, it's like we wrote up there before. I'm going to have 2 intervals. The left-hand boundary of my first one is going to be -infinity. It's going to go to -3. It's not included. We're going to union that with something that started at 6, and I goofed up because that should be a bracket. 6 to infinity. Okay? And we've taken care of that. Let's say there isn't anything special. Basically, we have 2 intervals on the same graph, and we'll see if we get to the special circumstance, because I'm not for sure if the special circumstance will get in here or not. I divided by a -3, so we do have to pay attention that we're going to change that inequality sign, so x is greater than 3. When we subtract the 5 over, we get x is less than -1. So now it's just paying attention to your open and closed circles. And moving on with that. So we have 3, and we're going to go greater than. We have -1, and we're going to go less than. And interval notation then, I've got an interval that goes from -infinity to -1. It's not included, so it gets a parenthesis. We're going to put our union symbol, and then we're going to go 3 to infinity. Again, there's nothing, we haven't hit anything special. Again, it's just doing multiple intervals, inequalities on the same one. And now we're just getting to multiple step things. 17 minus 9 is 16. We're going to divide that 2 out of there and find out that x is greater than 8. We'll subtract the 10. Divide the 5 and find out that x is less than 0. So again, both of these are open circles. So we got an open circle at 8. We're going to go to the right. We got an open circle at 0, and that's going to go to the left. My intervals, I've got a -infinity to 0. My other interval started at 8, and it went to infinity. So again, there's what we have as far as when we're looking at our intervals, determining what we're going to do with those. We add the 14 over to get 7x is greater than or equal to 14. So when we divide the 7 out, x is greater than or equal to 2. Subtract the 5 across, we're going to get a negative 8. Divide out that 4, I guess that's a 4. Bless you. And we get a negative 2. So again, nothing special here. It's just more of the same. Fill that in at 2 and we went greater than. Fill that in at negative 2 and we went less than. So my two intervals go from negative infinity to negative 2. We're going to union that with another interval that went from 2 to infinity. In our last example, I'm going to do it a different way just because we can. There's just that one product over there, so I'm going to divide by negative 3. I divided by a negative, so I can remember I'm going to switch that. It's inequality sign. We're going to subtract the 1 over there and get 2x is greater than 4. And so with my remaining space, which is none, we get that. This was a good reminder to switch signs because this is another one where it has a sign switch. We'll have to divide that. We can't leave the negative variables, so we're going to switch that inequality sign. And again, there's one special case. I don't even think we'll even talk about it. So anyway, we went to the left of negative 4. We have an open circle at 2 that we went to the right of. Negative infinity is the left boundary. Negative 4 is my right boundary. We're going to bracket that in. This was an open circle, so it gets a parenthesis. That left boundary is 2, and it's going to go on to positive infinity. So there are OR problems. OR problem are going to have oars in the boat. There's going to be 2 of them. Okay? And problems tend to have a bar. Okay? So there's going to be 1. So if we look at this, so we started at negative 6, and we went to the right, and we went to 1, and we went to the left. Now, so coming back up here, I didn't do a very good job. So if we looked at this problem as a whole, okay, what I'm saying is when I looked at my solution set, I could pick any number I want to. It just has to make one or the other true, meaning if I take a number, let's say here is negative 6. Okay, we're going to use negative 6 as my example. So negative 6 minus 4 is less than negative 7. Negative 10 is less than negative 7, which is true, so that's fine. If I went 2 times negative 6 is going to be greater than 12. That would be negative 12 is greater than 12, which is not true. However, this is an OR problem, so one or the other needs to be true. If you took a number that was in the middle, so we'll change color, we'll do red because that's bad. Here's 0 in the middle. Okay, that doesn't look like a 0. Okay, if we tested that out and we went with, where am I going to squeeze this in at? 0 minus 4 is less than negative 7. Negative 4 is less than negative 7. That's bad. 2 times 0, that's greater than 12. Well, that would be 0 is greater than 12. That is bad. So it didn't meet, and again, we knew that from my solutions. This fell on the gap. It has to make one or the other true. It doesn't matter. Okay? When we come down here to an AND problem, on an AND problem, both intervals have to be true. Okay? So, I'm not for sure what this example was supposed to be. If we look at this interval notation for my answer here. So I am true from here at negative 6 to 1. My intervals are overlapping, so we'll highlight that. This is overlapping, which is what I need to happen. So at that, in this little interval, I should be making both of them true. So let's look at that. Okay, We're going to pick 0. Is 0 greater than negative 6? Yes. Is 0 less than or equal to 1? Yes. So on the AND problem, both have to be true. So therefore, anything in this interval is true. So my left-hand boundary is going to be negative 6. My right-hand boundary is going to be 1. And that is going to be my solution set. Okay? I'm not sure exactly what the rewriting the AND inequality is, but we'll write both of those at the end. So here these are written in compound form, so which I really don't like, because when we go to solve absolute value inequalities, we have the 2, but we'll work with it. So what happens here, I see many of you draw vertical lines on your paper at the equal sign. So that's what that's imitating. So if I'm going to get x by itself, I need to subtract 4. But what I have to remember is I've got an inequality over here, and I've got another inequality over here. So there's actually 3 areas that we'll be subtracting 4 from. So 2 minus 4 is a negative 2. X is the only thing left in the middle. And then 9 minus 4 is going to give me a 5. So that's what we have. So instead of writing the two interval things like we did up here, okay, this is a compound from the start. Okay, so we know that x is, so this is written backwards, and that's the funny part of this is, so my x values have to be greater than negative 2. So here's a closed circle at negative 2. And it's all the values that are greater than that, so it would go this way. Okay? At the same time, we'll do it in a different color. We've got another interval that starts at 5, and it goes to the left. But since I have to make both of them true, this is going to be the interval for my answer. So my solution interval is from negative 2 to 5. And actually, I drew this wrong. This 5 should be an open circle, but I drew it as a closed circle. Okay, so it looks like we have 4 of these to walk through. We're going to add the 13 over. But there's going to be 3 parts that we have to do it to. So this is going to give me a negative 14. That's going to give me a 7x. And that's going to give me a 21. So we'll divide that 7 out of there, but I got to divide the 7 to all the parts. So negative 2 is less than x, which is going to be less than 3. And in reality here, again, if we look at that, negative 2 is going to be an open circle. 3 is going to be an open circle. It's going to be all the values in between. Looking at my interval notation, my left-hand boundary is not included, so it's a parenthesis at negative 2. My right-hand boundary is also not included, so it's a parenthesis at 3. And there we have the interval notation for that. We're going to add the 4 over to get a negative 12 and a 6. We'll divide the 3 out. Let me get that 2 in there. All right, so that means that we're going to go from a closed circle at negative 4 to a closed circle at 2, it looks like. And we're going to connect the dots. So again, my left-hand boundary is a negative 4. It's going to be a bracket because it was filled in. And we've got a 2 over here, so that will fill in that one. Okay? All right. Now, I forgot, this is we're doing this during advisory, and I forgot about my advisory check-in, so we'll see what we can do here. We'll get to these 2 examples. I guess they're going to have to be on hold for a second. All right, second verse, same as the first. We're going to subtract 1, subtract 1, and subtract 1. So that means we're going to have a negative 2 is less than 2/3 x, which is less than or equal to 4. Again, this is a multiply by the reciprocal thing, so we're going to multiply by 3/2. We're going to multiply by 3/2, and here we're going to multiply by 3/2. So I'm only left the 3's and the 2's cancel, so that's why we did that. All right, so sorry, I was getting lost here. Over here on the left, so the 2's cancel. I end up with a -3. My 2 goes into my 4 twice, so that leaves me with a 6. And so that means that we're going to have a -3 as my left boundary. We're going to have a 6 as my right boundary, and it's going to be everything in between. Okay? Benton, Cayley, Faruth, and McCoy give me 3 minutes here to finish up an algebra video I started. I just need to finish because I have no way to pause. So hang tight. This one, number 10 here, it works a little bit different in the fact that we're going to divide that 2 out. We could distribute, true. But I'm going to divide by a 2 to get that taken care of. -1 is less than x minus 6. We're going to keep that sign, so remember the equal to, and we're going to have a 2. We're going to add 6, and add 6. So we got 5 is less than x, which is less than or equal to, I added 6, that's an 8. Okay? So again, here's 5. That's not 5. Here's 5, and that's supposed to be, look at that, screwed up again. I'm trying to hustle through this and make all sorts of errors. Open circle at 5. We're going to have a closed circle at 8. We're going to connect the dots. So again, because my left-hand boundary is open, it gets a parenthesis, and there's a 5. My right-hand boundary is closed, so it gets a bracket at 8. Okay? And I have probably hustled my way through that way too fast, but that's the way life is sometimes.